There it is. -2. Excellent. Okay, what two numbers do we fill in the blanks there, Jose?
2.
What? Oh, these blanks.
-3.
Yeah. And this technically should say third piece. And Shelby, what is x approaching as? What is y approaching as x goes to -3 from the left? Yes, and as I go from the right, Hazella, is also 2. So if you look up here, there it is. As I approach it from the left, it's 2. Yes? It is. What's up?
I thought as it goes from the right,
No, because as I'm approaching, as I follow this line, it's getting closer and closer to -2 or +2. It doesn't actually equal,
yeah, I got you.
but it's still approaching -2. Yeah, it's all about wordplay here. Good question. So now we figured this out. So as, whoa, just kidding. As x approaches -3 from the left, p of x approaches, and this is the top equation, 1/3 times -3 plus 3. That, by the way, is 2. And as x approaches -3 from the right, I use the last equation there. P of x approaches the absolute value of -3 minus 1 minus 2, which is also 2. So there's a point discontinuity. Because these two are the same, but they're not equal to what p of -3 was equal to. P of -3 was equal to -2. So it's off just a smidge.
So the test is over which?
It is over, is this 9?
Yes.
Yes, it'll be over 1 through 9. Good question. Okay, so continuity. In order for something to be continuous, both pieces must approach the same y value. And I'm going to call that y value b, just so I have a letter or something to refer to it. So they have to approach the same thing, but that's not enough. F of whatever number it is you're looking at has to also be that number. So all the ones that we did were not continuous, because even if they approached the same number, there was still a hole there because it wasn't the same value. There either wasn't a value or it was a totally different number. Jump discontinuity, this is just kind of wrapping up, means that both pieces must approach, somebody grab that. You're getting your steps in, Jose. Different y values. F of A may or may not be defined. So this is the one where they're going to approach totally different numbers. And it doesn't matter if it actually has a dot somewhere or if they're both open circles. There's still going to be a jump discontinuity. For point discontinuity, both pieces must approach the same y value, b, but f of a can't equal b. So, in other words, that can't be a filled-in circle. Now I'm going to start the bottom two, but it's nothing new. It's the same stuff we've been doing over and over again. So, you'll still be just fine, and I'm not even going to probably finish that tomorrow, doing homework 9. Make sure you do homework 9 if you haven't started on it yet, so that if you have questions, you can ask me these tomorrow. Okay, I'm going to skip around a little bit. Let's jump to number 3. Flip on the back. I may finish this tomorrow. We'll see. So, we are trying to, the directions say, determine if they're discontinuous, and if they are, then you have to tell whether it's jump or point. All right. So first, we start, there's 2 of them. We're going to start with these 2 right here. Notice how these 2 both have a 3 in them. So as x approaches 3 from the left, that means I use that top equation. Then h of x approaches 2 times 3 minus 3. So that's equal to 3. As x approaches 3 from the right, I'm going to use the second equation there. So that's 3 squared minus 2 times 3. And that's 9 minus 6. That's also 3. So this is either jump or point discontinuity, because those 2 are the same, or it's continuous. If h of 3 is also 3, then it's continuous. Can I find h of 3? And if so, which equation would I use? The third one is only for x is greater than or equal to 5. So which one is including 3? The second one. That may have been what you said, but I couldn't hear. So yes. So I plug in 3 squared minus 2 times 3, which I already did. That is 3. So h of x is actually continuous at 3. I picked that one because we haven't done one that's actually continuous. Make sure you work and do homework 9.